Hi, everybody, and welcome to week 5 of IT project management. So this week, as we've already discussed, we're looking at how to get from the scope statement to the tasks. Last week, we discussed the project process groups. Specifically, we discussed how to use the scope statement, and from the scope statement build the WBS, the work breakdown structure. And so this week we are going to focus on sequencing activities, estimating activity resources, and estimating activity duration, and so that we can at the end of this week come out with a schedule. So how do you get to the WBS? Well, last week we looked at just building a basic task list, and then taking that task list and figuring out what is all the work that needs to be done for example, the call center project, and how can I break this work down further until it cannot be broken down any further. If we have come to the point where the work activities, the tasks cannot be any smaller, that's the work package level. So this week, we're going to talk about project schedule and budget. Now, the assumption is that before this week, you have developed your WBS, your work breakdown structure with activities and tasks, and that you have your activities and tasks in Microsoft Project looking kind of like this. So this is where we're going to start. You do have, just so that you can follow along, a MS Project file or a Project Libre file, depending on what your favorite application is, in which to follow along. Before we go into estimating, however, we really need to talk about the WBS again, specifically about how we can decide which tasks are going to run in parallel, like here, and which tasks have to occur sequentially, like these here, right? First, we have to get the approval to install, then we can install the hardware, not at the same time. So we need to really understand who is available to perform the work, and that has to come along with, has to be a consideration that also informs this connection that we make between tasks and the ways in which we choose to arrange the tasks, either simultaneously or in sequence. So who's available to perform the work? That depends on the kinds of skill levels that we're looking for. Are we looking for a junior or a senior programmer, for example? The experience, are we looking for a person with a lot of experience in the company that we're working with, or a lot of experience in the industry that we're working with? Vacation time as well. Are these people available at all to work on our project, either in terms of being here or being available and not on vacation, or also, do they have any other competing projects that would impact how much of their weekly time they can spend on our project? So all of these are certainly considerations. And then, along with that, really, we need to understand, as we move from our WBS to our schedule, we need to understand, is there anything we need to order? If so, if we need to order materials, how long in advance do I need to have to order them until they come in, especially if they are custom-made materials, let's say, custom built. Also, do I need to, are there any services or is there any work that my organization does not have the capability for? If so, who can do this? Who can sell this kind of work to me? And at that point, we are at hiring developers with specific skills and so on. And then we need to also understand, well, is there a way in which I can maybe just purchase complete results? Anyway, having said that, the most important thing to understand is all of these factors will influence your make or buy decision. The make or buy decision being that you literally are considering, am I going to work these tasks in-house, or am I going to purchase them from outside? If I'm deciding to purchase them from outside, There's a whole lot of work that goes into that, and that's called the procurement management process. It starts with drafting a statement of work and publishing a request for proposal depending on how big that amount of work is that I'm trying to outsource. Then evaluating the RFP responses that come back, maybe even holding a bidder conference, especially if the proposals really vary in price structure, and then figuring out which source to select. Now, in some cases, source selection has already been done for you, in which case you have a sole source situation in which there's only one vendor that's offering exactly what you need, or you have a single source, which is a preferred vendor for the company, basically. So, along with that, you need to know your contracts as well, because as you are getting ready to move from WBS to schedule, it's important to understand what the performance incentives are for people to work faster or to work not so fast. So firm fixed price, for example, is really where the buyer pays the vendor a set amount, and that's it. So in other words, you get $500,000 no matter whether you complete the work in 3 months or whether you complete the work in 5 months. Well, of course, in order to really get the best value out of the money that I want to make from my client, I will try to complete the work within the 3 months, right? So cost reimbursable, on the other hand, is the complete opposite. The cost plus means that every month the vendor submits to the client an invoice, basically. And that invoice contains all the allowable costs, and there's a cost dictionary in which those are defined usually. And so these costs are being paid. And this also means that the budget is a whole lot more open. And here, if I'm the vendor, I will try to stretch the budget as much as I can by providing extra good service without violating any scope definitions, because scope definitions are certainly still intact, right? So the buyer risk, of course, increases with cost reimbursable. The buyer risk is very small with fixed price. However, the vendor risk is really large with fixed price, because you never know what you're going to get, right? And you've just sold your services for a fixed price. Here, the vendor risk for the cost reimbursable contract is much lower, because if you find something unforeseen that needs to be fixed, for example, you can actually bill that to the client. So and then we have time and materials contracts. Time and materials are things like the plumber coming in, that kind of thing. So why are we talking about all of that? Well, because IT is a very special animal among all other industries. IT services are typically outsourced. That means somebody is purchasing IT services, or maybe you are in an organization in which you will be purchasing IT services. And purchasing IT services then really has to occur within within a number of different models. So we have full insourcing, which really doesn't happen anymore. Most often we have IT services that are selectively outsourced, like, for example, just the IT, the hardware support, or there is full outsourcing in which all IT function, which is hardware support, software support, licensing support, and everything else is outsourced. You don't have that all that often either. So now, just as a reminder, there's two different types of outsourcing, right? So outsourcing basically means that you purchase work from the outside of your contract. That can be your vendor contract with your client, which is what we have in Health IT Pros, or that can be really it can be that you're the organization who purchases, like the client who purchases work, in which case, of course, our client, for example, Diagnostic Imaging Associates, would be outsourcing their IT work to Health IT Pros. So, but the other facet of outsourcing is that I purchase work from offshore. That means from somewhere else in the world, but not from my direct continent. And that is called offshoring, of course. And offshoring in itself has a number of complications that we need to keep in mind as we build our schedule from our WBS. For example, if I'm based here in the United States and I'm working with a offshore contractor in India, I have 11.5 hours time difference. This also means that when I am at work, I don't have the luxury of just calling my colleague in India to get an answer to a question. Most likely that person is asleep. And similarly, when that person has a question and tries to call me, most likely I'm asleep, since our days are really switched around 180 degrees. So that kind of communication lag, for example, is only one example that can impact our schedule generation, and that we need to be extremely cognizant of. So lastly, as we look at our outsourcing activities, of course, always ask yourself, should you outsource something or not? Also, to what extent can you still control the quality of the outsourced activity and the schedule? Because right now, as you are responsible for a project schedule and you have outsourced an activity, you have to monitor their schedule as well, your vendor's schedule. And and that can get very dicey at times. So now, these here are the steps in project procurement management that we kind of touched on at this point. Project procurement management is in fact a PMBOK process group. And so the most important thing here for your management, from your management standpoint, is to control the procurement, right? And that's what we just discussed. So let's assume you have your WBS. As I said in the introduction, you've got your activity durations, because now you know who's going to do the work, how long it's going to take them, right? You've most likely figured out, well, which activity is going to come first, which one comes next, and how is the activity distributed, etc., right? Then we can go into our project schedule management. So we start our project schedule management with sequencing activities. Now remember, now we go back to this, and we test if this is really true. So as we sequence our activities, we use what's called the precedence diagramming method, which basically means we have an activity A, we have an activity B, and we figure out how they're related. Typically, we have finish to start, that's sequential relationships among tasks, that say, well, if A takes 10 days, B takes 4 days, and A has to be finished so B can start, then the entire process from A to B takes me 14 days. That's the most common way of relating tasks. There's also finish to finish, meaning that activity B, for example, has to cannot be finished until activity A finishes, in which case then we would have to wait for activity A to finish, like for example an approval, and B would be preparing, or would be talking about the approval, and would be talks about the approval, and so on, right? And we also see that if B is delayed or A is delayed, that delays B, right? But the point is, A has to be finished in order for B to finish. Ideally, they can run in parallel. They can also run sequentially. That's the worst case scenario, though. Now we also have finish to start we also have start to finish relationships. Start to finish relationships means that A must start before B can finish, right? Which means that even if A starts on the last day that B finishes, it still has started before B has finished. That's the worst case scenario. Best case scenario are A starts first, B starts later, and they both finish at the same time. And then we have start-to-start relationships. Those are slightly more common, where we have to have two activities that have to start at the same time. That's a start-to-start relationship. Ideally, then A will start and B will start simultaneously, or if B cannot start until A starts, then A can start and go on for a number of time, ideally, or worst case scenario for the entire length of time, and then B can start right there. So that's what's called activity on node, because these here are called nodes. Nodes are being represented with rectangles. Yeah, so remember your task list? This is your task list. Your activity here has just an index here from A through J, could also be from 1 through however, right, from 1 through 10. That could work as well. So, and then you have your estimated duration here. And then you can start figuring out, well, what has to come first so that the next activity can start. So here, we have for A, evaluate current technology platform, B, define user requirements, and so on and so on. And we see here, there's the predecessor. Here is no predecessor. So A is the first one. And the estimated duration is 2 days. A is the first one. Estimated duration is 2 days. B, define user requirement. Estimated duration is 5 days, and the predecessor is A. That makes sense. B, 5 days. Predecessor is A. Very good. So now, here we go. Whoops. So now we have here 3 tasks whose predecessor is B. Designing web page layout for 4 days, setting up the server for 3 days, and estimating web traffic for 1 day. And here, predecessor is B. Now we know that B takes 5 days. So we write a 5 on each of these arrows, right? We've got C, D, and E here. The arrow that goes out of C is 4 days. The arrow that goes out of D says 3 on it, right here. And yeah, and then another arrow that goes out of D, of course, also has to say 3 on it because D is 3 days long. And the arrow that goes out of E is 1 day. So there you go. So the next thing that we want to take a look at is testing web pages and links. The predecessors are C and D, and the estimated duration is 4 days. Okay, so F is connected to C and D, and the estimated duration is 4 days. And then we have G, moving the web pages to production environment. Estimated duration is 3 days, and the predecessors are D and E. Okay, so we're looking at G, predecessors are D and E. We don't change anything here because those are the durations of D and E, right? But the durations that go out of G are 3 and 3 here. And then we see that H, right, in announcements, is connected to F and G. So right here, right? We don't change these again because these are the durations for 4 for F and 3 for G, right? So H is 2 days long, so it gets a 2 right here. And then we have I, training the users. The predecessor is G. There you go. We don't change the 3 because that was the duration of G. So for I, we have a duration of 5. Let's see if that's correct. Sure thing. So, and then our last node is J, right, the report to management, and the predecessors here are H and I. This is what's called a network diagram. So, now let's talk about something that you always will see it's called critical path. Critical path is one of the major items, major aspects of schedule management that you will have to manage, because the critical path is the longest duration to get from A through wherever you have to go, right? So here are all the paths. We're going to look at all the paths that get us from A through J. So one of these paths would be A, B, C, F, H, and J. Another one would be A, B, D, F, H, and J, or A, B, E, G, I, J, and so on and so on, right? So altogether, we have about 5 possible paths here. And then all we do is we add up the durations of these paths. And the path that is the longest, right, the durations that we have here on these arrows. And the duration that's the longest shows us which the critical path is. So this critical path, A, B, D, G, I, J, A, B, D, G, I, and J. That's the longest path. So while we can, while we have to take a look at certainly the execution of all of these tasks here, this path we need to very closely monitor as our project progresses. And a lot of project managers forget to monitor the critical path, and all of a sudden tasks are late, and then the entire project is late. Because on the critical path, whenever a task is late, the entire project is late. All the other paths are shorter than the critical path. So if on path 3, a task is 3 days late, it still does not impact the end date of the project. Anything that impacts the end date of the project would be longer, or would create a path through the network that is longer than 19 days. So now, can the date math get any more complicated? And the answer to that is yes, it can. So here we go. This is our, this is the same network diagram here. I'm going to make this a little bit bigger. So in order to figure out, we just said the critical path is 19 days. We have some places, or we have some paths that are 16 days. So how can we determine that the which tasks could potentially be late, or where we have a little bit of wiggle room? This is where we start with our calculations to find float. Float is the wiggle room between tasks in your network and the critical path. Now note please that any task on the critical path, for us here, A, B, D, G, I, and J, always has a float of 0, because they determine the length of the project. So there is no float, there is no wiggle room, they have to be completed on time. So let's see here. For our early start of A is 0. We always set that to 0. Our early finish then is 2. When can B start? B can start on day 2 when A finishes. And the early finish for B is 7, because 2 plus 5 is 7. Let's go to task C. The early start for task C is 7, because that's when B finishes. And then because C is 4 days long, the early finish is 11. So for F, the early start would be the end of C, 11. And then the early finish would be 11 plus the 4 days that F takes to complete. So the early finish would be 15. And so on and so on. So, in other words, we come out here at J with, oh yeah, we should probably talk about that. So the most important things is when you have two arrows going into a task, right? You have to understand what the relationship is to the task beforehand. If it is the finish to start relationship, which as we noted before is the most common relationship, then this task, or this task specifically, can only start when both tasks that come before it are finished. So let's walk through this. We know that B finishes at 7, so D can start on 7, and because D is 3 days long, the earliest finish is 10. Now, we know that E follows B, and so the earliest start is 7. E is only 1 day long, so it can finish on day 8. However, do you see that? G can only start when D is finished, and since E also has to go into G, here we already see we may have 2 days that we can be late with task number E, right? So the early start for G is 10, the early finish is 13. For I, the early start then, because it follows, is 13, the early finish is 18. So, and now for H here, same principle, right? The early start for H is the end of F, obviously, right? Which is 15. Oh, it's not 30, right? Because H has to wait until F is done. Even if G is done at 13, F is done at 15, doesn't matter. H can only start when F is done, because it's the longest. So, and even though H takes only 2 days and is done at 17, that doesn't mean that J can start. J has to wait until I is done as well. And since I starts at 13, but it does take 5 days, the early finish is 18. So J can only start at 18, not at 17. So now that is the forward pass that we call it the forward pass that answers the question, how early can an activity start? The backward pass is where we calculate the durations from the end of our schedule to the beginning. So we go backward in order to figure out how late an activity could potentially start. So here we're going to start with J. We're going to say, well, J has its early finish at 19 days. Since it is on the critical path, the late finish also is at 19 days because there is nothing we can do about that, right? So the early start, because it takes 1 day, is 18, and the late start is the same as 18. So now we're going to check. So for J, since the early start is 18, or the late start is 18, late start, we're going to say if we remove 2 days, so 2 days earlier than J, we have to have H starting, because it has to complete at 18, right? So that makes the late start 16. All right then. So now we can say, well, now let's go to F. So if the late start for H is 16, which is 18 minus 2, then the late start for F will be, well, the late finish has to be the 16 here, right? 16 minus 4. The late start would be 12. So now, the late start of 12 means that C, which is a predecessor of F, can finish on day 12. So the latest it could start is at 12 minus 4, namely 8. And that also means that as soon as I go here, I can go back from C to B. I can say, well, so I have here my 8, which would be the late finish of B, but oh goodness, wait, B is a critical path task. So B obviously has no float, there is nothing we can do, right? So our float that we can use here is that we potentially start task number C late. However, we cannot finish B late because B is on the critical path. So, so in other words, here's another example. Really, why were we doing this? We're doing this in order to figure out how much an activity can be delayed because things happen. People get sick, like me today, or people have emergencies that they have to attend to and they can't be available, or problems with the work appear and they cannot finish their work on time. So we'll have to figure out where we will, at what task steps we will not have to worry about the schedule too much, and at what task steps we will have to worry about the schedule. We always worry about the schedule when something happens to the critical path here. How much we worry about the schedule when something happens to a task that has float, namely where we say, well, if the early finish on this task is 17, the late finish is 18. This means we have 1 day of wiggle room here, 1 day that this task could potentially be late, right? Critical path tasks, of course, have an early finish that's identical to the late finish. So here, for example, task number G, marked in red, so we know it's on the critical path, has an early finish and a late finish of 13, so there's no float. So now let's see. Let's run through a little bit of an exercise here. And yeah, so here we have Jane, the marketing manager of Hit Pros, and this is about her 3 best people, Mike, Helga, and Ping, to convert the Pilot Angel scheduling system from HTTP to HTTPS, right? So, well, Jane says it's going to take 2 days to design. Public key and server setup is 10 days after the design is finished. So we know that B is successor of A is a predecessor of B. Port implementation is 5 days after design is finished. So we know that C is a successor of A, and A is a predecessor of C. Browser customization takes 2 weeks after the design is finished. Oh, look, again, it's dependent on A, okay? Testing is 2 days after all the development activities are finished. Now we're going to assume that all of these, B through D, are development activities. And then F, we have to purchase an SSL certificate. So that takes 3 weeks. Now let's see. How can we do that? So we would have to say, well, here's design, public key and server setup, browser customization, and SSL certificate. Go right back here. We know that design takes 2 days. Public key and server setup takes 2 weeks. Now that was a work week, so we calculate 5 days, right? That's 10 days. 10 days here for browser customization. SSL certificate purchase would be 15 days. We know that port implementation is dependent on the public key and server setup, and that testing has to come afterwards. So all of these activities have to converge in testing. All of that we get from here. So, and then we have the 2 days that the testing takes to the end. So, how do we get the float? Why don't you take some time now and you calculate that? In fact, why don't you calculate that after our video? So now, let's see. This is the same diagram as this one here, and then you know that you have your 3 developers here, Mike, Helga, and Ping, right? And you're in the break room, and all of a sudden, you overhear Mike telling Helga that Mike has submitted a job application to Global Technology Solutions. So if he gets the job, he's leaving our company. Well, guess what? You're supposed to have 3 developers on the project, right? Well, now you have only 2. What are you going to do? At this point, it is a great idea to use PERT estimating. Now, you've read about PERT estimating in your book already, so this should not come as a surprise. First, we determine all the tasks in which Mike would be participating. One of them would be the public key and server setup, browser customization, port implementation, and testing. Because he's a developer, so he's going to participate in all of these tasks, right? So this also means that if we have to go from 3 to 2 coders, there is a potential that our schedule can increase by 33% because 1 out of 3 is 33%. So now, let's apply our PERT formulas in order to determine how long the schedule is really going to take, especially if Mike leaves, right? So here are our optimistic durations. Here are our pessimistic durations. You see here to 10, I have added 3.3, right, because that is 33%, and so on and so on. So now, if I round my pessimistic estimate to full days, then all of a sudden my public key and server setup, which if Mike stays takes 10 days, really is much more likely to maybe take 13 days, right? That's the pessimistic. So now, what we're going to do is we have our optimistic and our pessimistic estimate, right? PERT takes the optimistic estimate and the pessimistic estimate, and then takes the most likely estimate, right? The most likely estimate is always taken times 4, then we add the optimistic and the pessimistic estimate, and we divide all that sum by 6. So and that's exactly what we're going to take a look at now. So, now, if we decide that, here that these are our optimistic durations for those 4 tasks, these are our pessimistic durations for the 4 tasks, right? These are our rounded pessimistic numbers. Then here we calculate our most likely. Our most likely is we've estimated that maybe there is a chance that we can persuade Mike to stay. Maybe if we pay more money, or if we're nicer to him, or if he gets a promotion, that kind of thing, or a better office, right? So let's say that there's a 75% chance that Mike leaves. So here I apply my 75% to my optimistic calculation, and I get this here. I get these values, right? There you go. So, and if I do that, if I apply my 75% to the optimistic, and that gives me my most likely values, then I'm going to round those. And then I can see that my most likely durations would be 34. So now I'm going to apply my PERT calculation, in which I say the optimistic plus 4 times most likely plus the P divided by 6. And I do that for each of these tasks, right? So this task comes out at 12.2 days. This task comes out at 6.1, 12.2, and 2.44 days. So now, this allows me to build a much more realistic schedule, a schedule that has the risk of Mike leaving, which I didn't know about, but now I do. I've calculated that risk into my schedule. And that is one of the most important things when you build a schedule, is that you calculate the risks that you know about. There's always risks that you don't know about. That's what's covered in contingency. But the risks that you do know about, or that's what's covered in management reserve, the risks that you do know about, that is what you can calculate into your schedule. Now, there is an example in your Blackboard as well of this PERT chart, and you can see all the formulas here that I've used. Okay, so now let's see, what is the new float? I'm going to leave that to you to calculate. So how do you do that in Microsoft Project? Well, in Microsoft Project, what you do is you build predecessors, and that's what I'm going to show you right now. So if you open a task, I just opened here the Husky Air WBSN schedule, which is in your weekly content file right here. There you go, right there. Yeah, and the PERT example, by the way, is right there. So I've opened that here, and you can see you have a tab that's called predecessors. And in the tab called predecessors, that's where you set the predecessors here. The determined scope is dependent on composed MOV. So here, that's what you're seeing. If I make it dependent on another ID, let's see, ID number 4, meet with client to discuss requirements. Oops. As you see, I've just typed the 4 in here, and that does this here, right? And then what you also see is that there is a new arrow here that points from this task to the next. All right, so having said that, as soon as you have built your dependencies, as I'm showing here in Microsoft Project, you can also just type the predecessors in. That works as well. Hang on, let me show you that. There you go. So you have, in fact, if you expand this here, you have a predecessors column. You see this here. So I can here for the identify alternatives. I can do a 6,4, and then that will have built for me a connection between those two tasks as well. So, all right, and I'm just going to use the 6 here. So, the same way, the same thing applies to Project Libre here. With task, as you can see here, you can double-click a task, and you have the predecessors here as well. And for the predecessors, the most important thing to do is to type them in here. There you go. And then you will see that the predecessor appears right here. Okay. So that's this. And that's how we build this in the Husky Air schedule. Now, one thing that I wanted to show you is the Gantt chart, which is the WBS on the left side, and then the bar schedule on the right side is not the only way in which you can represent your schedule or your project. In Microsoft Project specifically, you have a number of views. You can represent your project with calendar, with a PERT chart. Now we don't have in this schedule specifically the most likely and the optimistic and pessimistic. So the PERT chart basically looks pretty much the same as what we would see in the Gantt chart. However, we also have, and I want to show you this, the network diagram. Remember the network diagram, right? So here we can see specifically start, finish, right, of each task, and then we can also see here notes as we click on the tasks, right? So, and then in our network diagram, if we make it a little bit smaller, we see that there is a path in red here, and well, you guessed it, that's the critical path, right? So There you go. All right. If you have any questions, or if you need to hear the forward pass and backward pass calculations from someone else, I really encourage you to watch these two videos. They basically do the same thing that I just explained. Yeah, and then I'm wondering, are there any questions, or is there anything that I can do to help? And if you could please type your questions in the chat box, that would be great. All right, if there aren't any further questions, then I'm going to end this meeting. And I thank you very much for your attendance. I will make the recording available later. Yes, thank you, Navina, for the question. I'm just going to have to convert it and put it online, okay? So thank you so much, and you have a good one. Okay, thank you, Navina, and yeah, talk to you later, okay? Good. Bye-bye.